Thank you so much for the opportunity to present at the World Cancer Congress. This is my first meeting of this kind, and I've had quite cherished interactions with a lot of clinicians and researchers. I'm going to continue the recurring theme of breast cancer. That's my area of subspecialty interest in Sydney. It's also my area of research interest. So you've heard a lot about proteomics, genomics, integrative medicine, and a few other branches. What I'd like to focus on today is on a subgroup of metabolomics called lipidomics. And I hope to share with you some data in screening. So let's take a brief walk back into time. Breast cancer was known 3,000 years ago, and Hippocrates described it 400 BC. There's papyrus texts on breast cancer, but really the Renaissance happened with the advent of anesthesia, and that was only about 100 and something years ago. So really we need to walk back in time in order to see how far we have come. Sorry, these slides aren't advancing. The mouse isn't working, so I'm going to use the laptop itself. In the interest of time, we're just going to fast forward to 20 years ago, which is the era of genomics. So the whole human genome was only mapped under the Clinton initiative 20 years ago, and that's seen an explosion of all things we have been talking about over this weekend. So really, the four major subtypes of breast cancer, which have been elucidated by previous speakers, to the luminal A, luminal B, HER2 enriched, and triple negatives have been well discussed, well known about. Are there other ways to categorize and phenotype breast cancer? And the one thing to point out is that breast screen, at least in my country, which is a Medicare funded system, is already 3 decades old, and it's already getting outdated. So this is the landscape of breast cancer in my country, in Australia. And the figure to note here is that 1 in 7 women in my country will get breast cancer. And as a trainee, which was about 14 years ago, that figure when I was training was 1 in 11. So I don't think we've hit a threshold yet either. This has shown no indication of plateauing. What does this look like on a global scale? You can see for yourself what that looks like in the US, and what that looks like globally, and what that's looking like in India. You've seen recurring slides this weekend about that being the top female cancer. We need to do something better, don't we, than clinical screening or imaging screening with mammography. There are currently no simple detection monitoring tests available for breast cancer, one that is easily accessible to everybody. And the limitations of mammography, lots of them are self-evident, but really the bottom line, and even in an affluent country where I practice, is that 50% of eligible population do not attend screening, which is free, because it's uncomfortable. It's a recurring biannual screen, and it's limited by lots of factors, including breast density, but access being key, particularly in a country like India. So these are the kind of figures and amounts spent in affluent countries on screening. Whilst there are no blood and plasma tests, mammogram and ultrasound are the backbone of current screening elsewhere in the world. So biomarkers really have opened the door to explore other opportunities for good, robust screening. And lipid expression is one of those. So lipid candidate markers can reveal a lot of differences between breast and non-breast cancer patients. Why do we choose lipids? What do they tell us? Well, they're fundamental components of all cells. They're involved, we know, and these are, I've listed the data and the science behind the evidence that there is progression. They're involved in the progression of cancer, they're the building blocks of cells. They're also involved in the metastatic processes. They're involved in cancer stem cell regulation and in signaling pathways. And they're involved in evasion of immune surveillance. So there have been many studies all the way back into the early 1990s. So lipidomics is not a new science, looking at this as a potential promising tool for breast cancer detection. But the fact that breast cancer can be differentiated into its subtypes is a recent phenomenon with this particular branch of molecular science, and it's only a couple of years old. It also can indicate the severity and the stage of breast cancer, and it can even distinguish between benign and breast disease, including DCIS. It can also be used in the surveillance setting for monitoring response to breast cancer treatment, including chemotherapy, and for recurrence. So the rapid advancements in the recent years have seen this particular subtype of metabolic phenotyping focusing on high lipid profiling and throughput. And really that comes down to BCAL, the company that has developed this particular algorithm, and how they got to the point where this is now a patented, marketable tool. So simple blood is collected at the point, a few mils, spun down to separate plasma from its components. So remove the red cells, remove the 1% white cells, and what you're left with is the plasma. Lipids are extracted, and then with a process familiar to some of you, which is liquid chromatography mass spectrometry, we're able to analyze a particular algorithm of lipids that are very much prognostic and predictive of breast cancer and its subtypes. The historical way that this was done was not through plasma, but with the use of extracellular vesicles called EVs, which was thought to be a more robust way to study it. So these are the studies to date in the last 4 years, looking at 4 cohorts. Cohort 1 was a smaller sample of 88 patients, all stages of breast cancer. Cohort 2 had only early stage breast cancer. Cohort 3 had a mixture of 1 and 2. Cohort 4 included stage 0 or DCIS as well, and every one of these cohorts was matched to a control. And this is the way that the algorithm was developed. So the biomarker discovery summary, and note that this is under IP, so while I can give you details of how it was developed, can't tell you how the potential 10 to the power of 30 trillions of options distilled down with machine learning to 18 lipids out of a panel of 450 in the initial phase. And these were derived from extracellular vesicles and then applied in the next-gen studies to plasma successfully. So the algorithm development and the biomarkers, they were trained on these 4 BCAL cohorts of cancer patients with the matched controls, and they distilled these 450 lipids to this very fine group of 18, of which 6 were truly prognostic. And what did they perform like? So this is some of the data that I presented at ASCO in June of this year, looking at these ROC curves. Now, the summary here with the ROC curves is that the line that is closest to the left-hand side gives you closest to best sensitivity and specificity. So you can see that these ROC curves for performance have shown a close to 0.9% sensitivity or 90% sensitivity and specificity. How robust is this data? Well, it was independently reviewed by a blinded statistician at Cambridge, and these are her data. So the results actually found that we could use a considerably refined group of biomarkers, as few as 6 to 10, to be prognostic. I've only got 4 minutes more to go. So when we started with EVs, this was thought to be a more robust platform, and then we moved to test in plasma. And the next few slides, which in the interest of time I'll skip through, are all showing that the ROC curves are sitting with the same 0.85 to 9, sensitivity and specificity 0.88 here. So remaining strong across plasma in all the cohorts. This was our poster presented at ASCO in June of this year. So I have no conflicts of interest. I am an oncology advisor for BCAL, but I have no financial disclosures. And I guess the only other disclosure to say is that my interest in bringing a test like this to a geography like India is because this is where I grew up. I grew up in Hyderabad before I moved as a teenager to Sydney to pursue medicine. And one of my interests is equitable access and affordable access to screening. So In the last couple of slides, I guess my plea is, that is the catch cry slide. This is the incidence. Let's, I guess, flip the paradigm for breast cancer in a country like India, where 80% of patients are diagnosed at stage 3 and 4. And let's see if bringing an early lipidomic, easily accessible test with a few mils of plasma is able to detect cancer much earlier. So our next step is for an international multi-center clinical validation study, which is underway. And we would like then, for all the reasons mentioned by speakers in the previous day and a half, to test this in the Indian population, because we know that cancer is heterogeneous. There is a spectrum of cancer that is triple negative, higher grade, in a cohort of patients that are a decade younger than the Western, in the Western setting. And we would also like to look at a retrospective sample for testing the robustness of the test and improvement work. So I guess the mission here is to invite interested colleagues. Many hands make light work. Let's put our hands together if there are clinicians and researchers in the room who would like to participate in adjunctive tests to mammographic screening, which is an interest I know at the KIMS Hospital in Hyderabad, where I'm speaking on Tuesday morning. That is one way of collaborating. Another is to monitor the breast cancer progress through its life cycle, so in the surveillance side of things. I was particularly interested to hear about the BRCA preponderance in the group that presented yesterday from Bangalore Baptist Hospital, I believe, who had a 28% BRCA positivity. That would be a very interesting group for us to apply the BCAL algorithm for, and of course, as a screening tool for all patients. And I might just stop there in the interest of time, but happy to take questions.